Hi, good evening, everyone. Today we are going to go ahead and take a question which came in DEPR 2008 paper. This was for 5 marks. Let us try to see how to solve this question. It says, given the production function, you're given this production function, show that factor share are constant. So the aim is to prove that the factor shares are constant. So how can we go ahead and how can we try to solve this question? See, we want to talk about the share of factor. Actually, just by looking at it, you should know that this is a Cobb-Douglas production function. And the share of labor is alpha and the share of capital is beta. You should know this much. But still, we want to go ahead and we want to prove this thing. So how can I go ahead and how can I do this? To go about it, let us say that marginal, I'm going to tell you each and everything related to this production function. So marginal product of labor is how output changes as labor changes. And this can be written as A naught e to the power lambda t into alpha L to the power alpha minus 1 into k to the power beta. This can be written as A naught into e to the power lambda t into alpha into L to the power alpha by L. We can do this. I have just, so this is alpha minus 1. So which means that this would have been, I mean, this is basic. You should understand this, that this should have been when base are same, power gets added. So this should have been something like this. And L to the power minus 1 can go in the denominator. So it will be L into K to the power beta. Okay. This is going to be A naught into e to the power lambda t into L to the power alpha into k to the power beta into alpha upon L. This is also clear to you. Now, if you notice this part is simply y, because this is exactly what I'm having here. This is just y. So I can say that this is going to be y into alpha by L. This is marginal product of labor. So the marginal product of labor is nothing, but it is y by L into alpha. Now, if I ask you, what is the equilibrium condition? The equilibrium condition is where the wage is equal to marginal product of labor. So how much wage do you give? You give wage equal to marginal product of labor. This implies that W will be equal to this, right? So from here, I know that W into L by Y will be equal to alpha. And WL is what? The money you are spending on labor. L is Y is what? The total value of your output. So we can say that this is nothing but this factor that we have got. This is nothing but it is the share of labor in output, and it is coming to be alpha, which means it is a constant. Okay. Now let us go ahead and do a very similar thing for marginal product of capital. So I am given y is equal to A naught. Then what am I given? E to the power lambda t L to the power alpha k to the power beta. So what will be marginal product of capital? It will be how output changes as k changes. So if you differentiate, you will get A naught e to the power lambda t L to the power alpha into beta k to the power beta minus 1. So I can write this as A naught e to the power lambda t L to the power alpha into beta k to the power beta by k. So I can rewrite this thing A naught into e to the power lambda t into L to the power alpha k to the power beta by k into beta. This is nothing but this is y into beta by k. What happens at equilibrium? At equilibrium, we have R is equal to mpk. Sorry, this is k, huh? So you will have R is equal to y by k into beta. So you will get R k by y is equal to beta. So this is nothing but this is the share of capital in output, and it is coming as constant. So therefore we can say that share of labor in output, it is constant at alpha, and share of capital in output, it is constant at beta. This is what we have to prove. So usually whenever you look at Cobb-Douglas production function, right, these powers that you see, this power, these are actually shares of labor and capital. And this is what we wanted to go ahead and prove. Okay, we will meet in the next class. Thank you.